They're in contact, no? How the normal contact force will act along the line of impact. So this is the center of two spheres. So the normal contact here, I'm showing it here. Actually, where we have to show, we have to show that here only. So to make you understand, I'm just showing it here. And here it will act in this direction. Is it fine? So the normal contact will act in this direction. Now let's see that he himself is telling it will rebound. It will, the sphere 1 will retrace a path. So I'll call V1. How the sphere 2 will move? So this angle theta is given for us. What can happen now? What are unknown things? The speed of the sphere is 1 and 2. Soft impact, how do they move? How do they move is what we have to check it. Now this component of Jn, so what it will do? It will act along x as well as y axis, no? It will act along x as well as y axis. So Jn cos theta, what it do? It will try to impart the momentum to the sphere, second sphere along vertically down. So what this string will do, suddenly the string will be jerked. And because of that, an impulse is set up in the string. I'll call JT. How this JT has come? Because of Jn cos theta. Jn cos theta, what it will try to do? It will try to pull this Jn cos, it will try to pull the sphere vertically down, as there is an inextensible string. So therefore the string will be jerked, and impulse JT will act here. So this was overall sequence it happened. So because of this, now can this Jn what happen? Finally JT will become equal to Jn cos theta. The impulse will be nullified here, net impulse. Only Jn sin theta will act on the sphere, second sphere along x-axis. So because of that, it will move in this direction. So why the second sphere will have only horizontal velocity? Because the JT will become equal to Jn cos theta. Means a jerk is produced, and that jerk, what it will do? Set up an impulsive tension is set up in the string, and that will nullify the impulse due to normal contact along y-axis on the second sphere. What are unknown things? V1, V2. We'll take help of conservation of linear momentum. Next question comes. What are the directions? So there are two things are then. This is the line of impact. There are two things are there. So one, this is the line of impact. So in which direction I can apply conservation of linear momentum? Along x-axis, can I conserve momentum? The answer is no. Any reason? Or answer? First, along line of impact. In short, I'll write LOI. I just assume if there are different radii, we can work out. Just to make problems simple, to avoid mathematics, I made them of same radii. If there are different radii, then you should calculate the line of impact, how it will get oriented. Later we'll discuss some other problems. No, this is about the line of impact here. Along common normal, it will be directed. No, is it momentum conserved along line of impact? The answer is no, because component of JT cos theta will come into picture, you see. So momentum is not conserved along line of impact. Is it momentum conserved along y-axis? No. Jn cos theta, Jn cos theta. But what about JT? Unbalanced. So therefore momentum is not conserved along x, along line of impact, along y-axis. Pi, y. So or we'll write in terms of statement. Momentum is not conserved along line of impact and along y. The reason for that, JT non-zero. So therefore, in whichever direction if you want, you cannot conserve. What you have to check? You have to check, is it linear impulse 0 or non-zero in that direction. Okay, after this condition, now can I conserve along x-axis? Yes, we can conserve. Because what is the Jn sin theta? Jn sin theta. And what about here theta? Jn sin theta. So net impulse along x-axis 0. And what about JT, sir? Component of JT along x-axis will be 0. So therefore, net impulse along x-axis is in fact 0. Along line of impact, component of impulse will come jt cos theta. So therefore momentum is not conserved. Look at jt cost is unbalanced, no? So therefore momentum is not conserved along line of impact and along y-axis. And now applying conservation of linear momentum. Initial momentum m1, I'll write all set of equations here. Applying m1 u sine theta minus m1 v1 sine theta plus m2 v2. How many unknowns are there? v1 v2 are two unknowns. I need one more equation. So what is one more equation from where I should bring? I'll take help of quotient of restitution formula. According to quotient of restitution formula, what is E? You can write it as velocities of the velocity of separation along this one. E is equal to, I'll define this direction as positive. Anything you can pick up, let me take this is positive. So therefore, what is like a velocity of colliding objects? So this will be theta. So v2 sine theta. So if you still find very difficult, you directly draw one line of impact. Show all the velocities. So initial velocity how much? U. Final velocity of the first pair v1. Then that of second pair after impact how much it should be? v2 sine theta. You come for here. This is theta. This angle will be theta here, no? This angle will be theta. So v2 sine theta will come, and this is line of impact. And I think by having this diagram, anybody can write equation. Now, what is the quotient of restitution formula now? E equal to v2 sine theta minus of v1 by plus u minus 0. Solving this, we'll get EU is equal to v2 sine theta plus v1. Solving 1 and 2, we'll get expression for v1, v2. Now few questions. The problem will not get over here. I may trouble you if I ask this in more than one option. No? What are the other things I'll ask you? What about the, I'll show complete diagram. Huh? It's visible. Just make careful observation. No? There's any loss in kinetic energy here? Yes, the kinetic energy is lost. The loss in kinetic energy, what happened? I'm asking this question. The loss in kinetic energy here, so I'll put it like this. Kf will be less than Ki. Any reason for that? Because inelastic collision. As E is less than 1. And normally, what happened? That delta K, loss in kinetic energy. Conservation of momentum, m1 u sine theta, m1 u sine theta, m1 v1 sine theta, velocity of this, v1, m1 v1 sine theta, m2 v2. And now loss in kinetic energy, where do it will go? More than one options. Okay, everyone knows how to solve this. Writing equation. Now just make a line. The loss in kinetic energy. Tell me where all that loss. That only Vn sine theta, no? See, V1 sine theta. This is a V1 sine theta. So M1 V1 sine theta. M2 V2. I wrote all things clearly. Equation 1. You make observation. Now, loss in kinetic energy. The loss in kinetic energy, what will happen? A part of that energy will be utilized to deform the bodies. It can happen. Next, a sound will be generated, heat will be generated, and also there will be impulses set up. No, string is jerked, and you know whenever string is jerked, there must be some heat generated. So here the delta K will be utilized in many ways here. The heat generated in string will be due to this parameter only. Now you have to be very careful. the heat generated in the string is due to impact only. So the delta K, what happened, the loss in kinetic energy, a part of that energy is utilized to deform the bodies, to increase potential in the bodies. Next, heat generated. Next, some sound will be generated. You know, you throw some stone against wall, or two billiards, or two balls when they collide, or two vessels in the house they collide. You get a sound, no? Inelastic collision only. So heat generated in the string is also due to delta K. Delta K will be converted as, will be available as deformation energy of bodies. Next again, sound, heat, and heat generated in string. Now this is really troublesome for you. You have to be very careful. So when they ask you a question, try to bother about what happened after collision. Next one, if it is a, instead of string, let there be a spring. Let's see what conditions will arise. That ball as one system, then okay, but it's of no use, no? If we consider that upper wall string balls as one system, then the net impulse along y-axis would be 0, right? Yeah, depending upon what you define system, but it's of no use. Balls you should